All right, here we go, folks. We're going to do some electrical review today with our digital volt ohm meter. We're going to build some different circuits. We're also going to do some relay testing, talk about circuit protection, and I've got a lab that goes in with that portion. Okay, so with the breadboard, it's nice. As we know, it really represents a car battery. With us not having to be out in the shop for this, we can go right to the 12-volt selection here. And it'd be the same thing as if you were at that positive and negative cable of your car battery. So we're going to start off with a very simple circuit in review. Then we're going to take some measurements of that circuit. We're going to build a series circuit, which means that the current has to go through everything along the way. That one doesn't fit so great. We're going to try this one here. That's a better fit. And after we come through the power side of the switch, we're going to go through 2 bulbs today. Current goes through this bulb, through the filament, onto the next, and back to a source of ground. I flip the switch, it's very dim. So take a close look, folks, and notice how dim these lights are. As you remember, these lights are dim because it's a series circuit. The current has one way to travel through it, and we're going to do some tests with this today. So we're going to start off by testing resistance, but when you test resistance, we don't want current flowing. So to make things simple, we're going to just disconnect it over here, and I'm going to grab my leads here, and oh, I forgot to tell our cameraman, sometimes you do have to touch the screen on that one to wake it up. It will go black on you, and it'll be hard to see. So feel free to just touch the screen as needed. If you look here, we have 4.8 ohms. Okay, now that's with the switch in the on position. If I close it, OL stands for out of limits. Yeah, that's got too much resistance. We cannot measure it. Out of limits. So remember that. We're going to go back and forth today with that continuity measurement. If we want to measure voltage, though, okay, we're going to come back over here, turn the switch on. The available source voltage for the breadboard on the circuit comes in at, let's see what we got here. I'm trying to read this upside down, and it's showing me a bad reading because look, I didn't turn it to the right selection. That's a nice thing about the breadboard, is that it's circuit protected. So I got a really weird reading. It's still like 1.99, so I still got a reading. That's where this understanding of basic electricity is very important. Now, 12.05, that makes more sense, okay? Is it's supposed to be representing a car battery. If you wanted to look at voltage drop, gotta remember that circuit's gotta be on, current's gotta be flowing. So I can look at voltage drop across this bulb, and it shows I've got 5.8 volts. We're losing as the current goes through this bulb. Okay, it's going to be different in parallel, so I want you to remember that. Remember the dimness of the bulbs, and remember the reading that we also had there too, as we were looking at that 5.8 in voltage drop. Now we can also measure voltage drop differently. We could come up here and measure the voltage on that side and measure the voltage on this side and subtract the two, or we can go right to it, and the meter does that for us. Moving right along here to amps. You got to remember, to measure current, measure amps, we need a load device on. Our load device is on. And as I turn it over to the big A, it's not going to work until I move my lead over to the big A for amps. And if you ever want to test it to make sure your fuse is good, it says lead. That means that we have it hooked up incorrectly. So we're going to open up the circuit over here. We're going to take the current through that, and the bulbs light up, completing the circuit. And this is not a very accurate reading. That's the bad thing about these breadboards, folks, is you find that the current continues to drop, and it should not do that. We see that with this conversion from alternating current to direct current, but you will not see this on your automobile. Okay, as long as the load device comes on and you get a reading, you're doing your job correctly. So we've done all that good so far, but now we're going to talk about a parallel circuit. So we're going to modify this just a little bit, and I'm going to take my power source over here. I'm going to power this guy up over this way. And I'm going to add another wire here to my power source. Okay, I'm going to move this over a tiny bit. So we have two different ways that current's going to flow as I hook up the ground side of it, creating a parallel. We got one way there. Notice how it's already getting brighter, isn't it? And yes, right away that parallel circuit has two different pathways. The current is going to travel a little bit differently. So let's just see what that looks like now. I'm going to turn my meter back on now to the amp meter side of it. I'm going to open up this branch of it. I'm going to complete it. The bulb comes on, and we're going to see a different value. But given that we really didn't have an accurate value here with the amp meter being used and so forth, we're hooking it up. We're taking the reading properly, but our reading's not ideal on the breadboard. We're going to go on to voltage drop. Okay, so I'm going to hook that back up. Got to remember to move that lead over. Okay, and if you remember before, wow, that's a lot more, isn't it? We saw around 6 volts, now we're seeing around 12 volts. That's because of the additional current available. Okay. Now when it comes to measuring resistance here, I could measure resistance of the entire circuit if I wanted to do so. We would need to have that switch in the on position though. And I turn it off, out of limits. We don't have current flowing. Okay, infinite resistance. We can also measure things individually. Maybe you just want to measure a bulb here. We can do that. 4.7 ohms. It's a dual filament. Let's see if the other filament has the same resistance. No, it's a little bit different. So this type of bulb will be used in the back of your vehicle for a brake light and for a tail light. So that's all been in review so far. Hopefully that's kind of a good refresher for you. Now we're going to move forward a little bit here. Okay. And we've got a couple different types of relays we're going to look at. A standard 5-pin and 4-pin relay is good circuit protection for your vehicle. We typically see them used on horns, fuel pumps, and things of that nature. And we have a lab sheet that is going to follow along with that. So we're not going to go over the very top part of it, but when you get down into here, this illustration is going to show us exactly what those little pins are supposed to do. So I've got one here that you can see. I've got Ohm's law in the background as a good refresher for you too. But I'm going to zoom in a little bit here, and it's really hard to see, so bear with me here. I got to tilt this just right. You can hopefully see that now on my screen. You see that 86, the 87, okay, and 30 and so forth. Those pins identify some very important things that we're going to see on our actual lab sheet. So I wanted you to be able to see that. And I'm going to back up here so you can see Ohm's law. And we're going to go ahead and do a relay test that matches the lab rather well. Okay. That was not supposed to be part of the video, folks. It's a good thing that we have a good meter though with the rubber case on it. Sorry. All right. The relay that we're going to use is a 4-pin. That it's really kind of nice too. It shows you everything here that's going to match up with the lab. And one of the first things that we're going to do as we move into page 2 is to test some very specific terminals with our ohm meter. Okay. And as we do so here, you're going to see that we're looking at terminals 87A and 30, okay, to see if we have an open or if the circuit is closed. So if it's open, what should the meter be saying? It should say OL, okay, infinite resistance. So it's closed, we're going to get some kind of reading. The first thing we're actually going to check will be terminal 86 and 85. And just to check our time here, how are we looking there, cameraman, on time?
9 minutes and 30 seconds.
That's perfect. Excellent job so far. Thank you again for your help. So I'm going to come up here and with my ohm meter set up, okay, it's asking me to check right over here between terminal 86 and 85 for continuity. Okay, 86, 85. Wow, that's a lot of resistance, 120 ohms. Okay, so bear with me. Now we're going to see something happen that I think is kind of interesting here. And we're going to actually hear the relay make a contact. So there's a mechanical movable wiper arm inside of this guy that's going to change positions when it's engaged. So when you turn the key on for the fuel pump on your vehicle, this is happening every time you start your car. You just don't hear it because it's hiding underneath the hood and the relay panel. So we're going to see if we can actually hear it today. The next part of our lab has us doing a test though first with the ohmmeter. We're going to test 87 and 30. And as I test 87 and 30, it's out of limits. Now what I'm going to do next you normally would not do unless you know for a fact there is not current flowing through the circuit. I know that, okay? And the lab sheet is written to keep our meter safe. If we don't know that, you would not want to use the ohmmeter in a circuit that you're supplying it with power and ground. So moving forward here, the next thing that we're going to test is continuity with, again, between 30 and 87, which we've done. But now we're going to hook up a jumper wire. And we're going to go from 86, okay, to B+. That's what the lab says to do. And we're going to go over here to 85 to ground. Now we have continuity. But we also heard something. So as I hook up the ground wire here, hear that noise? So it might be a little hard to hear. I'm going to do it one more time for you. A little click. Okay, that is that movable arm making the contact. And now we can see that when we disconnect the ground wire, we're out of limits. We have a closed switch. So now we know we have a good relay. That's very important, folks, because I'll tell you what, I've worked on cars where people thought, the car needed a fuel pump and all it needed was a relay. And a lot of aftermarket accessories come with relays that you need to install. But now, hopefully, you have a solid understanding of how a relay works and how to test it. Now, the next part of our lab that we're not going to spend a lot of time with today does revolve around you and our good friend Ohm's law. That relationship between voltage, amperage, and resistance is critical as we build a solid foundation in our understanding for electricity. So I'm going to skip over just a little bit with the airbag portion, and I really do want you to spend some time as you finish your activity today to go ahead and really apply the equation I've got on the board behind you, okay, to Ohm's law. Now realize it's going to be a little bit different on that series and that parallel circuit, as you have multiple branches flowing through versus only one way for current to travel. And there is a last page here today too, and it looks like this. So these pages are designed to really recap everything that you've done on the breadboard today. I hope you enjoy today.